Hi, welcome back to Sunex and our verbal blog. So today we want to talk about something that's very important for digital imaging. It's lens image circle and how it relates to the sensor size. It's not always intuitive how this works, how the image circle relates to image circle size, so we wanted to go through it real quick, and you can read more about it on our online blog. But essentially, what I have here are just three generic sensors in kind of a typical, say, 4:3 aspect ratio, and we want to talk about how different image circles influence different imaging formats, if you will, on the sensor. Now, I think it's clear to everybody that lens image circles are round and sensors are square or rectangular. So you might think there's some kind of incompatibility there with regard to field of view and so forth, but we'll clarify that too. So a lens has an intrinsic field of view based on its focal length, and the lower the EFL, the wider the field of view of the lens. That's just optics from a lens standpoint. But when you put it on a square sensor, what actually happens is the sensor is going to clip some of that field of view. And so what we often talk about is not field of view of the lens, but field of view on the sensor. And let's see how that works. If we take our first sensor here and we draw an image circle, first of all, note that I'm drawing it across the corners, because in this instance we want to make sure that we don't have dark corners. We want to be able to use the whole sensor, and for that reason the image circle of the lens needs to be larger than the sensor, at least as large as the diagonal of the sensor. And you can see that although the field of the view of the lens might be, I don't know, let's say 100 degrees, you're actually clipping off with the sensor some of that field of view. So the horizontal field of view you get might be less than the lens's field of view, and that's why it's important to have the same language when we talk about field of view of a lens. It's not usually relevant what the field of view of the lens is independent of a sensor, and that's the same reason it's also not usually useful to talk about the EFL of the lens with relation to the field of view, because what really determines the field of view at the end of the day is the sensor size. Now, that's not always true. EFL is oftentimes important if you're doing something that relies on a specific magnification or something like that. But when we're talking about field of view, this phenomenon, how big the sensor is on the image circle of the lens, has more impact on that. And you can imagine that if this sensor were this big, the lens would still work just fine, but instead of 100 degrees or 90 degrees, you might only be getting 40 degrees field of view on a smaller sensor. The other thing I wanted to point out here is that this configuration here, where the image circle fills the entire sensor, is what we refer to as a full field of view, meaning you're getting the full field of view of this lens in any dimension on that sensor, horizontal, vertical, or diagonal. So what's the alternative, you might ask? Well, you can always do this. You can always have a lens that does this. So what I've drawn here is a lens that has a full horizontal field of view, meaning that you get the full horizontal, but you're still getting dark corners. Now, why would you want to do this, you might ask? Well, there's a lot of applications, police wearable cameras is one of them, where you don't care so much about what's in this direction, but you care a lot about what's in this direction. And so what you may want to do is maximize the horizontal field of view you can get from a particular lens. And there's a number of reasons why you might not be able to do this. I mean, doing both would be ideal, right? But if you want very wide field of view in the horizontal, sometimes this is your best option. So there's other formats that you can imagine as well. So let's take a look at this one here. This is what we call a circular fisheye. And this will utilize the full horizontal field of view and vertical field of view of the lens on the sensor. And so you'll get, let's say the lens's intrinsic field of view is 180 degrees. You will get 180 degrees in any dimension. And some people call this a 360 degree field of view, because you get 360 degrees all the way around. That's really more of an application-based statement. You can imagine this lens on a ceiling pointing down, and you would be able to see 360 degrees around. Really what this represents is a hemisphere, so it depends on your point of view. If you were to put this camera on a wall, for example, you would see 180 degrees this way. If you put it on the ceiling, you see 360 this way. So you often see this as referred to as a 360 degree or 180 degree image circle format. So you can see how the image circle of the lens can influence the format or what you see on the sensor, as well as the field of view in each case. So if you want to learn more about this, check out our blog, and until next time, thank you for watching.